Suppose that we have friends named Pete and Jane, and we want to know Pete's age. We know Jane's age, and we also know that Pete is 3 years older than Jane. Let's calculate Pete's age using the MIPS ADDI instruction. Suppose that Jane's age is stored in cell 5. Let's store Pete's age in cell 4. Then the instruction is add I, DST equals 4, SRC equals 5, and IMM equals 3. This instruction adds 3 to the value stored in memory cell 5, then stores the sum in memory cell 4. Next, suppose that we have a third friend, Beth, who is 7 years older than Pete. Let's store Beth's age in cell 6. Which of the following instructions calculates Beth's age? 1. Add I DST equals 5, SRC equals 4, IMM equals 7. 2. DST is 6, SRC is 5, and IMM is 7. And 3. DST is 6, SRC is 4, and IMM is 7. Pete's age is stored in cell 4, so SRC is 4. And the sum is Beth's age, which should be in cell 6, so DST is 6. Thus, choice 3 is the correct answer. In order to choose the correct instruction, we had to remember where Pete and Beth's ages are stored. We can easily keep track of 2 cells, but how about 3, 4, or more? For example, in the Fibonacci program, we need to remember 5 cells. Cell 1 contains the nth Fibonacci number, cell 2 contains the n plus 1 Fibonacci number, cell 3 contains the n plus 2 Fibonacci number, cell 4 contains the current counter, and cell 5 contains n. As the programs get larger with more instructions using more memory cells, keeping track of memory cells becomes more difficult. Is there an easier way? We can give the cells names. For example, let's say that we name cell 6 Beth age, and we name cell 4 Pete age. Then the instruction becomes add I, DST equals Beth age, SRC equals Pete age, and IMM is 7. Since the names describe the contents of the cells, we no longer have to remember what the cells contain. Another issue is that the assembly instructions are somewhat inconvenient to read and write. The MIPS instruction set is not very difficult to memorize, but if the instructions looked more like math equations or human language, we would have a much easier time memorizing them. For example, instead of the add I instruction above, what if we can write Beth age is equal to Pete age plus 7? Rather than writing add I, we use a plus sign and an equal sign. Now it is easy to see that Pete age and 7 are the operands. As before, the sum is stored in Beth age. In Python, this is called an assignment statement. An assignment statement consists of 3 parts: the target, the equal sign, and the expression. Here is an example. Tomorrow equals today plus 24. The word on the left of the equal sign is the target, and the operations on the right of the equal sign is the expression. In our example, target is tomorrow, and the expression is today plus 24. When an assignment statement is executed, the computer first evaluates the expression, then stores the result in the target. Thus, the target must be a label or name that points to a memory cell. For example, this is a valid assignment statement. Boiling equals freezing plus 100. But the following statements are invalid. The first statement is invalid because the left side of the equal sign must be a name, but 5 is a value. The second statement is also invalid because 5 plus y is an expression. The target must always be on the left side. The following text, tomorrow equals today plus 24, can be interpreted as both an assignment statement and as a mathematical equation. As an assignment statement, this text instructs the computer to perform a calculation and store the result somewhere, just like the ADDI instruction. As a mathematical equation, this text gives us information. The left side of the equal sign is the same as the right side. Python always interprets this text as an assignment statement, not a math equation.